In order not to overwhelm you with all the directives available in the CORTEX-M manual, I have selected 14 of the most frequently used directives so that as we go and we start writing in a practical way, when we come by new directives, we explain them as we use them. But we need to know these ones before we write our first assembly code. So the first directive is the thumb. This one is placed at the top of a file to specify that the code is generated with thumb instructions. Remember, we said there are 3 instruction sets by the company. The first one being the original 32-bit instruction set, the thumb, and then the thumb 2. The next directive is the code, and this denotes the section of machine instructions. It denotes that a particular section is code. A particular section is instruction rather than data, because usually what happens is instruction and data are taken, put together to get results. So the code directive denotes this is instruction, and the data directive denotes a section of global variables. We have area. Area instructs the assembler to assemble a new code or data section. Yes, when we start typing, you would see the relevance of area. Space reserves a block of memory and fills it up with 0. And align is used to ensure the next object aligns properly. The next one is the export. And what the export does is it makes your object accessible from other files. It's like declaring a global method. When you're talking about higher level programming, it's like declaring a global function so that you can call it from another file. When you add export to your code, then you can call that particular piece of code from another file. And global here has the same meaning as export, and import is the command used to access exported object. After that, we have end. The end directive is mandatory. It's placed at the end of each file. Never forget that. And then the next 3 instructions are used for declaring constants in memory. The DCB places 8-bit, which is a byte, 8-bit size constant in memory. The DCW places a half word, which is 16 bits size constant in memory, and the DCD places a word size constant in memory. The reason why we have DCB, DCW, DCD is for starters, you could say code density. If you have a value that you want to place in memory and that value fits perfectly in 8-bit, you could declare a DCB. You do not need a DCD to put 8-bit in to bloat it for nothing. So this gives us the flexibility to choose different sizes of constants. EQU is used to give a symbolic name to a numeric constant. The next directive is the .text, and by adding this directive to your code, this makes the assembly code callable from a C code. If you add this to your code and you have another code written entirely in C, you can call this piece of assembly code